All right, so for part A, we wanted to determine the equivalent resistance. Part B, the total current. Part C, the current going through the 330 ohm resistor. So let's do this. The equivalent resistance. So for part A, let's combine this, and then we'll combine this. So for the first part, that's going to be 1 over 560 plus 1 over 330 to the negative 1. When we actually evaluate that, so that's 560 over reciprocal plus reciprocal, and then we'll unreciprocalize the combination. That's a really technical word. And that's going to give us 219 joules. And then for these three, the equivalent is going to be 680 divided by 3. So that's going to give us 227. So when we combine to get the total resistance, that's going to give us 446 ohms. All right, now for part B, the total current, that's going to be V equals IR. So I is going to be 100 divided by 446. And that's going to give us 224 milliamps. Notice that's the same as 0.224 amps. All right, now the current going through the 330 ohm resistor. Let's see. So what we know is that we have a combination here of 219 and 227. So what I can say is, since the total current here is 224 amps, we know that 224 amps goes here and then out through here. So let's be really careful. First, let's split this battery. Here's what we're going to do with this circuit. We're going to look at it as a combination of the 100-volt battery, and then we have here the 219 ohm resistor combination, and then we have the 680 over 3, which is the 227 ohm combination here. Let's get the voltage. Let's get the voltage across this combination right here. That voltage is going to be 219 times 0.224. So V across this combo is going to be 0.224 times 219. So that's going to give me 49.14. So I'm just going to say that that's 49 volts right there. Now the rule for parallel resistors is, now I can take this 219 ohms and kind of write it as its original resistors. So we have here the 560 on top and the 330 ohm on the bottom. Since I have here 49 volts, that means there's 49 volts on the top one and on the bottom one. So now I on the bottom 330 ohm is going to be 49 divided by 330. And that's going to be 0.15 amps. All right, so that's part C. We want the current going through the 22 ohm resistor. So let's set up two equations. 10 minus 47 I1 minus I1 minus I2 in parentheses times 22 equals 0. Next, minus I2 minus I1 times 22 minus I2 times 82 minus 5 equals 0. So we've got these set up. So we're going to have, for the first equation, 10 minus 69I1 plus 22I2 equals 0. So that's going to be 69I1 minus 22I2 equals 0. Next. So this is just equation 1. This is equation 2. Rewriting equation 1, I get this. Let's rewrite equation 2. So I'm going to end up getting here a negative I2, and that's 22, minus 82I2. So that's going to be negative 104I2 and 22I1 equals 5. So I think I've got this set up okay. To be honest, I'm going to actually stop working here. I think on your real test, I may not make you solve for the entire current, only because I want to get at least the videos up so you can look at them. But I'm happy to check work, and I may work out a solution later. Here, to get the equivalent capacitance, in series, this is going to be 1 over 10 plus 1 over 30, and that's to the negative 1, because they're in series, and capacitors add reciprocally in series. So that's 3 over 30 plus 1 over 30. It's 4 over 30. So it's going to be 30 over 4 right here. And then we're going to add that in series with the 20, or in parallel with the 20. So when we add that up, that's going to be 110 over 4 microfarads. Which I think is going to be 27.5. Let's just see. 110 divided by 4. Yep, 27.5 microfarads. And moving on to here. I already got a little start on this. These 3 in series will be 6 divided by 3, which is 2 microfarads. What I'm going to do now is I'm going to actually replace them here. And that's 7, 8, and 9. Like this. All right, now I'm going to take this capacitor and I'm going to replace it. So that's C789. That's going to be 2 microfarads. Then when I combine these in parallel, this is going to get me C 6 through 9. That's going to give me 6 microfarads again. So what I'm going to do is I'm just going to kind of cover this up here. I've now replaced it with a 6 microfarad. I combine these in series again, 6, 6, and 6. All of that gets converted into 2 right here. So that C4 through 9 is going to be 2. So I'll cover all this up just to reflect that fact. And so I can combine the 2 and 4 in parallel again. So when I combine these, I'm going to get C3 through 9 is 6. So C total ends up being 2 microfarads. So there is a bit of a process here I'm not going to give you something this awful on the test, but I would definitely want to see that combined. I guess if you want to see more work on it, I'll actually write that up perhaps as a solution. But I want to see you do a little bit of this, but I don't think I'm going to give you a combination that bad on the test. All right, and then here. We want to set up and not solve the differential equation to determine the charge as a function of time. So you've got EMF minus EMF minus Q equals CV. So that means V equals Q over C minus I dq dt for the resistor equals 0. That's literally all we have to do for that. And that wraps up the circuit part of the test.